Hello everyone, this is Dr. Surya. Today we are going to see about sedimentation tank, that is the basics of sedimentation tank and a problem on it. So first of all, what is sedimentation tank? So sedimentation tank is otherwise called as settling tank or clarifier. Okay, so this is a component of your modern water supply or wastewater treatment system. What does it do? So it removes the heavy inorganic solids which is having a size more than 0.2 mm and specific gravity of 2.65. So mainly this is the one that is removed by your sedimentation tank. So this sedimentation tank, it will enable all your suspended particles to settle down slowly into the tank, and at the bottom of the tank your sludge will be collected and then you can eliminate your sludge off. So in order to enhance your sedimentation, so you can add, that is the sedimentation aided with coagulation is there. So you'll be adding you'll be adding the chemicals and you will be removing very fine and suspended particle that is present in the wastewater. The process of adding some chemical in the wastewater and removing of the very fine and suspended particle that is present in wastewater is termed to be sedimentation aided with coagulation. Many chemicals will be added as coagulants. So the main chemical will be your alum, or otherwise it is called as your aluminium sulfate. Then you will be adding your ferric chloride, so FeCl3, that is your ferric chloride. Then you can add your ferric sulfate, so Fe2SO4 and you can add your chlorinated coppers. So it is nothing but your mixture of your ferric chloride and ferric sulfate. So it is called as your chlorinated copper. Then you can add your ferrous sulfate. And finally you can add your lime. So these are called as your coagulants. So these coagulants are added to enhance the sedimentation activity or the settling activity. This treatment with bar screen and grit chamber is performed prior to sedimentation so that you will be eliminating your larger object and coarse solids. So after that it will come to the sedimentation tank. So in order to increase the purification efficiency, after your primary sedimentation there will be a secondary treatment, either your trickling filter or activated sludge or whatever it is, that is going to be the secondary treatment. So initially you will be having the wastewater will be passing through your bar screen and then grit chambers, and then it will come to the sedimentation tank, and here the particles will be settling down, and in order to aid the process we will be adding some chemicals or coagulants. And let us move to the problem. So a problem like design a primary settling tank for a town which is having a population of 50,000 and a water supply is about 180 liters per capita per day, and we have to design a rectangular as well as circular shaped tank. So none of the data is given, only 2 data is there, and remaining data we are going to assume. So first thing is that we have to calculate how much amount of quantity of water is generated. So quantity of water generated is equal to population into per capita demand. So that is the first thing, we have to calculate how much quantity of water generated. So that is population into per capita demand, 180 liters. Next is that you have to calculate what is the quantity of sewage generated. So quantity of sewage generation is very simple, which is going to be 0.8 times, that is we are going to assume 80% of water that is supplied to the city is converted into sewage. So which means 80% means 0.8 into 50,000 into 180 liters. So that is the amount of sewage that is going to be generated, and which will be equal to 7,200 into 10 power 3 liters per day. So you have to be very careful with the unit. Here it is given in 180 liters per day. So I am writing in liters per day. Now we can convert this into meter cube per day. Okay, so 1000 liters will be 1 meter cube. So now my total sewage flow will be, so if you see that you have got 7200 into 10 power 3. So you have to divide by 10 power 3 in order to convert this into meter cube. So now I will be getting 7200 meter cube per day. Now I am going to assume the detention period of 2 hours. Detention period of 2 hours. So what is detention period actually? So detention time is your average theoretical time required for the sewage to flow through the tank. In simple, I can say that the time that is taken for a particle to travel across the basin. So one single particle you can take. So from one end to the other end, how long the particle is taking place, how long time it takes place to move from one end to other end. That is called as your detention time. So this detention time for the sedimentation tank, we can assume it to be 2 hours. Now using this, we are going to calculate our capacity of the tank. Okay, so capacity of the tank is equal to 7200, and if you see here, the 7200 is meter cube per day. It is in meter cube per day, and detention period is in hours. So I have to convert this day into hours. So that's why I have to divide it by 24 into 2. So I will be getting my capacity of the tank as 600 meter cube. Okay, next we are going to assume another one thing, that is going to be the overflow rate. Okay, so overflow rate is 30 meter cube per day per meter square for an average flow. So this is also an assumption. Okay, so what is this overflow rate? So this surface overflow rate is going to be a very important factor because it affects the effectiveness of the sedimentation process. Okay, this is very important actually, and this overflow rate is used to determine whether the sedimentation tank is over or underloaded. So it is going to be, we are loading the tank highly or we are going to loading it very less. So that determines by the overflow rate. Okay, so it is nothing but your discharge per unit of plan area, that is called as your overflow rate, and otherwise it is called as your surface loading or overflow velocity. Okay, this is what, if actual surface loading is greater than the design values, then it indicates that the tank is going to be overloaded. So you have to be very careful, this as it affects the effectiveness of the sedimentation process. This overflow rate is going to be, overflow rate or overflow velocity is a very important one. Okay, now using this overflow rate, so this is also, overflow rate is also an assumption. So we are going to calculate our surface area. So surface area is nothing but your capacity of the tank, or it is going to be the total sewage flow divided by the overflow rate. So total sewage flow divided by your overflow rate, that is the surface area. So here the total sewage flow is 7200, overflow rate is 30. So I am getting my surface area as 240 meter square. Okay, now if you see that I know my capacity of the tank, so which has been already calculated as 600 meter cube. I have calculated my area also, so easily I can calculate my effective depth. Okay, so area into depth is going to be the capacity, right? So area into depth is capacity. So depth is equal to, depth or effective depth is equal to capacity by area. So capacity we have calculated as 600 and area we have calculated as 240. So the depth can be, the effective depth can be 2.5 meter. Okay, now this, up to this it is same. Now we have to design separately for your rectangular tank as well as your circular tank. So first we'll move on to our rectangular tank. Okay, so rectangular tank means you will be having your length and breadth. So here area will be your length into breadth, and that we have determined already as 240. And next assumption we are going to make, so which assumption is equal to L equal to 4B. So length will be 4 times the breadth. Okay, so now instead of L I will be substituting 4B. So 4B into B is equal to 240. So 4B square is equal to 240. So I will be getting my B as, that is my breadth, as 7.46 meter. So approximately my breadth is going to be 7.5 meter. So if breadth is 7.5 meter, length is nothing but 4 into B. This is what here. So 4 into 7.5. So my length will be equal to 30 meter. Okay, but if you see in sedimentation tank, there will be a separate setup for inlet and outlet. So what we are going to do is that we are going to add that also. So which is provide 4 meter for inlet and outlet arrangement. So water has to come and go. So for that we are providing 4 meter for inlet and outlet arrangements. Okay, so total length will be equal to 30 meter we have got, and this 4 meter I am adding. So altogether it will be 34 meter. This is my total length. Now if you take the depth we have calculated as 2.5 meter. But this is alone is not enough, because in the sedimentation tank the main process is that the accumulation of sludge. There will be accumulation of sludge at the bottom of the tank. So for that purpose we are going to add extra 1 meter. So which is provide 1 meter depth for your accumulation of sludge. Okay, so we have to provide that extra. So provide 1 meter for accumulation of sludge, as well as some 0.5 meter for your freeboard. Okay, so we have to provide this also. So my total depth will be 2.5 meter is a calculated one. 1 meter for accumulation of sludge and 0.5 meter for freeboard. So depth will be 4 meter. So now the dimension of the tank, dimension of my rectangular tank will be 34 meter, that is length is 34 meter, breadth is 7.5 meter, and depth is going to be 4 meter. Next we are going to design our circular sedimentation tank. So already we have calculated our area as 240 meter square. So the formula for area will be pi by 4 d square. So pi by 4 d squared is equal to 240. Okay, so from here d will be equal to, so you can keep your d squared here. So 240 into 4 by pi. And if you take the square root of this, you will be getting your d. So from here my d I am getting it as 17.5 meter. So the diameter of the circular tank will be 17.5 meter, and depth of the tank will be, you have to write the depth also. So depth of the tank is, we have calculated already, that is 4 meter. Okay, this is how you have to design your sedimentation tank. The other technical videos have been pinned in the description box. You can have a look and watch it and get a better understanding also. Happy learning and thank you.